To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the previous chapter we answered the sixth question in our essay type questions part. Now this is the seventh question, my dear children, right? This is the seventh question in our 2022 O-level essay type questions part. Okay, so let's see the seventh question. So as you can see here in the seventh question, my dear children, this is mainly regarding with the lenses and about the heat associated with the electricity part. So by just looking at the question, you can get a certain kind of an idea that this question relates with the physics lesson parts which we have learned during the grade 10 and 11. Mostly these things are related with the heat and with the current electricity and with the optics lesson part, my dear children. Okay, so first part of the question, which is part A, is composed of from the optics lesson part. So over there a certain two types of lenses given which relevant to their ray diagrams, right? And several questions being asked from the lenses, my dear children. Then after that you are given with a certain types of resistors, then given with a certain type of question relate with the voltage and find out the current over there. And so that lesson part is regarding with the current electricity part, my dear children, which we learned in the grade 10. Then the final part, part C, this is related with the heat and the electricity. Okay, heat and the electricity. So measurements related to electricity, and also, my dear children, about the power, then about the heat change associated with these kind of things, right? So those parts are being discussed at the final, or the question is related with the final question is related with the that heat associated with the electricity, that part. Okay, so this is the structure of the question, my dear children. Now let's head on to see the questions, and we'll answer the questions one by one each. Then, like in the previous sessions, finally we'll take the answer script and we'll give out the answers for the each correct answers. Right, so let's head on to see the first question then. So the following diagram illustrates how an object is placed between the optical center and the focus of a glass convex lens. So this is a convex lens, my dear children. When you place an object between the focal length and the optical center, right, what will happen? So you know that convex lens is the one, or the lens that we use as the simple microscope, which means, my dear children, when you look through a convex lens, we can get somewhat larger images, right? We can get, or we can obtain, or we can see larger images, somewhat larger images. So in order to obtain that kind of a larger image, we need to place the object in between the focal point and the optical center. Now it's been placed like this. So let's see what are the questions being asked over here. Copy this diagram into your answer script. Draw a ray diagram to construct the image formed. So now what you have to do here, you have to draw a certain ray diagram related to the formation of this image when the object is placed between the optical center and the focal point. So how to draw this thing, my dear children? You know that when we are drawing a certain ray diagram, we use two different kinds of lines. One particular line is the line which is coming, or the light ray which is coming parallel to the principal axis. What is the principal axis? So principal axis is the axis which runs in between the optical center like this. This is the principal axis. So first and foremost, straight line. Draw a parallel line, right? A parallel line starting from the, draw a parallel line starting from the head like this. You can use your ruler. It's important to use your ruler. Remember that thing, right? That's quite important. Don't draw it like by your own with a pencil. So within this board, my dear children, you know that I can use straight lines. So without any trouble, I can draw these lines. So however, but for you guys, you won't be able to write down the answers like this. So you are given with a certain paper. Definitely remember to write down when you are drawing these ray diagrams. Definitely remember to represent these things by using a ruler. Okay, right? So this is the first line like this. Okay, then the parallel line, the parallel light ray to the principal axis will always flow through the, right, or will always go through the focal point like this. Light rays which are parallel to the principal axis will hit on the lens surface and will refract through the focal point. This is the first theorem related to the lenses, my dear children, especially for the convex lenses, right? Then the next one is quite simple, my dear children. The second one, light rays which are passing through the optical center like this, they will pass in the same straight line without change in the direction, right? Without change in the direction, the light rays which are passing through the optic center, right, optical center, will travel along the same line. So it's better if you can mark the arrows like this to show the pathway of the light rays, my dear children. However, it's not that much important to mention the arrows, but however, it's better to mention it. Now, the thing is that we won't be able to create an image. You know that when the two light rays are being passed like this, the refracted light rays joins together to form the image. Okay. So, if the refracted light rays are not getting collected from the other side, what we need to do is we need to collect these to the other side like this, right? We need to collect these things to the other side like this. Always when you are connecting these lines by your own, remember these lines should be broken lines, my dear children. Okay, these lines should be broken lines. We'll use a broken line, a straight broken line. That's much better, no? So like this should be a straight broken line like this. Okay, so this is the diagram. Okay, this is the diagram. So now the image. So image is created like this. When drawing the image also use broken lines, my dear children, because always all the time when we are drawing a certain image, if the lines are being collected by our own like this, without joining the two lines, without joining the two light rays that are refracted away, if these two are not getting collected at a certain point, I mean, that's my whole idea. If these two are not getting collected, then by our own, we need to collect the other things to the other side. From the other side, we need to collect the two light rays, right? So, at the point which the two light rays are getting collected each other, the image is getting formed. But remember, when by our own, right, by our own, when collecting these two light rays to the opposite direction, definitely we need to put a broken line, right? It's because that, my dear children, these things are virtual images, right? Which means we won't be able to take these images into a certain screen or to a separate screen. It's only visible when we are looking at it. That's it. We won't be able to take that image into a different screen. That's why we are using these broken lines. Okay, right then. So this is the ray diagram related to the question. Then the next one, state two characteristics of that image. So you need to write down two features of the image which is created over here. So when you look at this image, my dear children, you can clearly observe, like I said, I told you that previously, this image is a virtual image, my dear children. Why it is virtual? Because we won't be able to take this image into a different screen. We can't take this into a different screen, my dear children. Right? There is no possible way to take this thing into a different screen. Just by looking at it, when I'm going to look through a certain convex lens, I could observe a certain image. That's it. Right? While I'm observing, I can see the image. That's it. If I'm not going to observe, then I won't be able to observe that image, and also I won't be able to take that image into a separate screen. So therefore, my dear children, this is a virtual one, a virtual image. Okay. So virtual image. Right? Virtual image. Then the next one, number 2, it is upright. Upright image, or else it is an erect image. Upright image or else erect image. Right? Upright erect means, so to the same direction which the object has been placed, for the same direction the image is also has been created. It's not upside down, right? It's not upside down in simple. Sometimes the images are getting upside down. If so, my dear children, then those things are inverted images. But however, this image is, according to the diagram, this image is same as to the direction of the object. So therefore, my dear children, this is an erect image or else upright image. Then number 3, right? Third feature, this image is magnified. Image is magnified. So you need to write down only 2 of these 3 features, my dear children, only 2, right? But however, I have mentioned all the 3. So image is magnified. Magnified means it is larger than the size of the object. That's what do you mean by magnified. If it is smaller than the size of the object, then we refer that thing as diminished. So this is magnified, okay, larger than the size of the object. Then it is an upright image. That means according to the direction of the object, for the same direction the image has been created, or else an erect image. Then this is a virtual image, my dear children, which means we can't take this image into a separate screen, right? So it's quite easy to identify these virtual images, my dear children. If the image is a virtual one, then the light rays are not getting collected. By force, we need to collect these 2 light rays from the opposite direction. If we can collect it like this way, by force we are collecting to create a certain image, then those images are virtual, my dear children, which means we can't take those things into a different screen. Okay, so these are the answers for the first 2 questions. So let's head on to see the next one then. So now the next question is related with the concave lenses. It's related with the concave lenses. So a concave lens is given here. Let's see what are the questions. Copy the given diagram into your answer script and complete the ray diagram. So you need to complete the ray diagram by copying down this thing into your answer script. Okay. So I'll take this thing to here. Then I'll draw and show how it is going to occur, right? First of all, we'll draw the principal axis. So this is the principal axis, my dear children. After that, the lens. right? This is the lens. Then my dear children, the vertical line, I'll use a broken line like this, like in the figure given here, okay? Then the point which that line intersects, right, the principal axis, that's the point which is named as C, which is the optic center. Then my dear children, we need to mark, right, we need to mark the focal point at the either sides, okay, focal points. So when you're marking the focal point, my dear children, it's important to measure, take a certain measurement and include the focal point over here, right? Take a certain measurement and include the focal point over here. That's the better thing to do, right? So remember, when you are taking this thing, my dear children, when you are marking the focal point, it's quite important. This is very important. So it's quite important to measure this focal point. Now focal point is located at the either sides from point C, no? So measure and take the focal point by your ruler. If it is not given in the question, how much is the focal length, then you can just measure and mention. So I'll show how to mention it. So I'll use the ruler, right? So I'll place the ruler like this from the midpoint, like this. Then what I'm going to do is, I'm going to mark. So from 5, I'll take like 4 centimeters, like up to here. This is 9 then. Then again from here, this is 1. Just need to mark it like this. That's enough. Now the focal points are okay. So from 5 to 9, 4 centimeters. Then here 4 centimeters once again. Right. So we have marked the focal points then. Focal point. Right. Now the light rays are coming, my dear children, parallel, right? Parallel to the principal axis. So this is the first light ray. Make sure to use straight lines. We use only broken lines when there are straight line. We use broken lines when there are, like imaginary ones. That means the light rays, the light rays we should, these light rays are not getting collected. So we need to by force collect these light rays to a different location, right? That's why we are using the broken lines. Okay. However, these lines are not like that. So we need to now draw how these light rays are being passed from the other side. That means refracted. So always, so here this one light ray which is coming from here also, it's been mentioned. So this is my focal point then. This is the focal point at the other side. Now, this is a concave lens, my dear children. Within a convex lens, you know that light rays are getting converged to the other side. But however, in the concave one, what will happen? The light rays are not getting converged, but those light rays are, right? What will happen? Diverged, right? These light rays are diverged to the other side. But the thing is, my dear children, these diverged light rays are getting collected, right, from the focal point at the other end. However, these things are seems to be collected at the focal point from the other end. So those things are the lines that we need to draw from the other side should be broken lines. So diverge the light rays. Diverge the light rays. So here also you need to keep your ruler. It's important to keep your ruler in here like this. Keep your ruler like this. Right, now you need to place the ruler like this, my dear children. Right, place the ruler like this so that it would pass through the focal point. It's important to pass that line through the focal point like this. right, like this. Place it like this so that you can see over here. Now the light rays should move along like this kind of a direction. So when you elongate it to the other side, it is getting collected to the focal point. Now we can draw the straight line. Right, so it should go like this. This is the pathway of the light ray. Then you should use a broken line to show that it is getting collected at the other side like this. Brilliant. Now use the ruler, place it at the other like this. Right. Place it from at the other end like this and draw the straight line. The same thing. It's quite important to keep your ruler and show that it is getting collected from here. Okay. Right. First of all, we'll draw the straight line which is coming from here then. Okay. Then the line. Right. Somewhat. All right then. So these are the light rays that are passing through the concave lens which is over here, my dear children. So this is the concave lens which is a diverging lens. So now you need to put the arrowheads correctly. So this light ray passing like this, this light ray coming and passing like this, and the light ray which is coming along the principal axis will travel in the same direction like this without any refraction. So this is the correct way of representing the light rays. Okay. Right. So whatever is the distance of placing an object in front of a concave lens, the image that can be seen has the same characteristics. State two characteristics of that image. So if you observe, right, if you observe images through a what? This given concave lens, you need to write down two features, two characteristics of the image formed. So my dear children, you can see that these images, or when you by just looking at the structure or the light rays, you can clearly see that these light rays are not getting collected at the other side, which means all the images which is created by the concave lens should be virtual. So virtual. One feature is this is B and this is A. Okay. Virtual. Right, image is virtual. It's because the refracted light rays are not getting collected at the other side. All of these light rays are getting collected from the opposite direction. That is also we need to join those things. Those things are not getting automatically connected. That's why those things are referred to as virtual images. The next one. The other thing is, as you can see here, when you join these images, my dear children, or when you join these straight lines, you can clearly observe that a small bit of very small image is getting created. That means these images, my dear children, always diminished images, diminished. Diminished images, that means smaller than the size of the object. Then the third and the final feature, right? There are three features, right? This is the third and the final one. When you collect these light rays, to the opposite direction. These light rays are always, my dear children, creating an upright image, okay? So, upright. So, the image is upright, the image is diminished, and it is also virtual. These are the three main features that we can observe within an image which is formed because of a concave lens, right? Concave lens. If you guys want for your betterment, I'll show how to draw a ray diagram within this, right? So this is the principal axis. I'll keep the object like in here. Then draw the parallel line. Then it is passing from like this, right? This is the first straight line. Then this is the next one. Light rays passing through the optic center. So the two light rays are not getting collected. See, the two light rays are not getting collected from this side. That's why I have drawn this broken line over here. So over here, you can observe the image, my dear children. So you can clearly observe that here by force we have collected the two straight lines or the two light rays. So this image is a virtual one. This is the image. See, this is the image created. So it is a very small image created between F and C, focal point and the optic center. And also, my dear children, it is upright and it is virtual because we by force collected the two light rays from the other side, right? These are the two refracted light rays. Those things are not getting collected, right? So this is the answer. These are the answers for the question then. So this is for your academic purposes, my dear children. For the academic purposes, I have drawn that thing. So these are the two answers for the questions A and for the question B, right? Okay then, let's move on to see the next question. Right, so we have finished the optics part then. Now the second question, second part. Assume that you are provided with 4 resistors, each with a resistance of 2 ohms. Draw a diagram indicating how those can be connected to obtain the highest equivalent resistance. So, asking about the equivalent resistance. So, equivalent resistance means the single value of resistance that can be applied to give the same effect for a series of resistors or for a system of resistors. Now here we are given with 4 different resistors with the same value, right? With the same value. Value is 2 ohms. Now you need to connect these 4 resistors together so that they would give out highest possible equivalent resistance. We know that, my dear children, if you take 2 resistors, if you join them in a series connection, one after the other, then, my dear children, the total resistance created within the circuit or created within the system will be created, or it will be the sum of the 2 resistors. It will be the sum of the 2 resistors. So if you connect 4 in the series manner, then sum of all 4 resistors is the equivalent resistance. We have a certain formula for this one. R is equal to, R means the equivalent resistance is equal to resistance first value plus resistance second value plus resistance third value, and so on. Okay. So here, my dear children, to get the highest possible, equivalent resistance, you have to connect all of these resistors in a series connection. Okay. So diagram indicating how these can be connected. So draw 4 resistors with 2 ohm each in a series connection, right? So you know that this is the usual symbol for a resistor. So 1, then connect the others, 2, 3, 4. Then all of these things are 2 ohm each. Or else, my dear children, there is another way of drawing. You can use a small bit of a rectangular shape. Small bit of a rectangular shape can also be used, my dear children. Like this. Three and 4. Like this way, small rectangles can also be used. Then you can draw the diagram. This is also used as a simple circuit symbol for resistor. So all of these things are 2 ohm each then. Both of these things are correct. Huh? You just need to write down only one, or just need to show only one. Both of these things are correct. This is also correct. This is also correct. Remember, there should be 4. 1, 2, 3, 4. Okay, 1, 2, 3, 4. 4 resistors of ohm 2. So total equivalent resistance is 8 ohm over here. Right? You just here the first question is asking only a figure. No, so this is the figure. Second one. What is the name used to identify the way the resistors are connected as mentioned above? So the way of connecting the resistors. The way of connecting the resistors, simple, my dear children. This method is referred to as the series connection. Series. It's not serious connection. Remember, it's not serious. It should be series. Okay? Series connection. Right? Series. Series connection. Series connection. Right? Series connection. Next one. What is the equivalent resistance of that arrangement of resistors? So you need to find out the equivalent resistance. So like I said, my dear children, when you connect 4 of these things together, right, like this, this is 2 ohm, no? This is also 2 ohm, 2 ohms and 2 ohms. So equivalent resistance R is equal 2 plus 2 plus 2 plus 2, which is equal to 8 ohms, my dear children. 8 ohms. The formula to calculate equivalent resistance, right? If the resistors are in a series connection, then my dear children, it's very simple. R is equal to, I'll mention that formula as well. R is equal to R1 plus first resistor, add the second one, R2 and R3 and so on. Add all of these things together to get the equivalent resistance if the resistors are in a series connection. Okay, so here there are 4 2 ohm resistors connected in a series connection. So therefore total equivalent resistance is equal to 8 ohms. Next one. If this arrangement of resistors was connected to a battery with an electromotive force of 8 volts, what is the current flowing through the circuit? Electromotive force, right? We can just take that thing as voltage, my dear children, right? It's not the voltage, actually it is the force by which the electrons are being expelled from the negative terminal towards the positive one. However, right, we can take that thing as voltage, no problem at all. There's a small bit of a difference between the electromotive force and the voltage. You will learn these things when you go with the higher grades, my dear children. But up to your level, you can just remember that electromotive force up to our level, that's voltage. So that's why even it is measured from volts over here, right? So you are given with the question, if the arrangement of resistors was connected to a battery with an electromotive force or voltage of an 8 volts, what is the current flowing through the circuit? So this setup has been connected to 8 volts voltage. You need to find out the current passing through the circuit. Then my dear children, what do you need to do? When you are learning about the current electricity lesson part, you have learned a certain very important equation. V is equal to IR. Voltage is equal to current times the resistance, right? So apply that formula and get the answer for current. So V equal IR, voltage is 8, current we don't know, resistance is 8 ohms. Divide both sides by 8. So if you substitute these things by using their international standard units, that means voltage is measured from volts, international standard unit, resistance from ohms, international standard unit, then we can get the answer of current also by using the international standard unit, which is amperes. So our answer is here 1 no. So answer 1 amperes. Always remember to write down their units, right? So 1 ampere is the answer. Right, next question. Right, so we have answered successfully for the questions given under the current electricity lesson part. Now let's see the question related to the heat and electricity thing. Okay, right. So the diagram shows a kettle with heat in coil. The kettle contains 1 kilogram of water. Okay, so kettle has 1 kilogram of water, my dear children. What is the main method of transmission of heat produced by the heat in coil throughout the entire mass of water? So this is a fluid, my dear children. Water means a fluid, no? Simple. We can take that thing as a liquid. So what is the main method of heat transfer in a liquid? When you take a particular liquid, what the main method of heat transfer is, my dear children? The convection. So when the coil is getting heated, water particles, right, will have a lesser density because the particles are getting expanded because of the heat. So expanded water particles will move upward, and to fill that gap, water particles from the top, the colder particles, will come down and they also get heated up and travel upward. So this is going to happen like a flow, as a current. So this is called as the convection, the convectional currents. So that's the main method of heat transfer in fluids. Fluids means liquid or else a gas. Both the things are correct, okay? So my dear children, this is a liquid. So in a liquid, the main method of heat transfer is the convection. Convection, it should be the answer then. Right? Convection. Convection. Next one. Calculate the amount of heat received by water when water in the kettle was heated from 25 degrees of Celsius to 50 degrees of Celsius. Specific heat capacity of water 4200 joules per kilogram per Celsius. Right, so the question is given now. You need to calculate the amount of heat received by water when water in the kettle was heated from 25 to 50. Specific heat capacity of water is given 4200 joules per kilogram per Celsius. Right, so we'll do the calculation then. What is the formula that you need to apply to here to find out the heat associated with this particular instance? There's a certain formula. H is equal to mc theta. H means the heat energy associated with the instance. Okay, sometimes it is also been mentioned as Q. Next one, M. M is the mass of the particular substance. Now here we are using, the question has given, right? When I was starting the question, can you remember? I was talking about the question. I was telling that it contains how much of kilogram of water? 1 kilogram of water. So mass of the substance is equal to 1 kilogram, right? So M means the mass. Then C means the specific heat capacity. That means to increase 1 degree of Celsius, to increase the temperature in a substance by 1 degree of Celsius, the amount of heat energy which is required. Okay, But however, this is calculated for 1 kilogram, right? So the amount of heat energy in joules that should be supplied to 1 kilogram of a particular given substance to increase the temperature of that particular substance by 1 degree, right? By 1 degree of Celsius. That's what do you mean by the specific heat capacity, right? So usually you don't need to remember these things because these things are given in the question itself, okay? So specific heat capacity of the water is given 4200 joules per kilogram per Celsius. Then theta means the temperature difference, my dear children, right? That means how much is the initial temperature, how much is the final temperature. So final minus the initial, that's the temperature difference, right? So here the temperature difference, my dear children, 50 subtraction 25 degrees of Celsius. Now let's apply H equal mc theta. We'll substitute the unknown things to the equation and we'll find out the answer. So mass is equal to 1 kilogram. Specific heat capacity C is equal to 4200 joules per kilogram per Celsius. The next one, theta is the temperature difference. From 25 to 50, temperature difference is 25. Now, first of all, Celsius to Celsius is getting cancelled. Then kilograms to kilograms is getting cancelled. So, from joules, we can get the answer. 4200 into 25 will multiply. 25 times 0, 0. 25 times 0, 0. 25 times 2 is equal to 50. 0. 5 is left over. 25 times 4 is 100. 100 plus 5, 105. What is the answer? From joules. Sometimes this can also be converted into kilojoules, my dear children. If you want, right? You know that 1 kilojoule is equal to 1000 joules. So you can cut these 3 zeros, that means divide by 1000 and indicate this thing by using 105 kilojoules. Okay, that is also correct, no problem. So 105,000 joules or else 105 kilojoules. Both the things are correct, but I'll keep this answer, right? So it's no need to convert this thing into kilojoules because it is not given in the question. So you can just keep the joule answer itself like this. So 105,000 joule is the answer. So when substituting, my dear children, it's not important to write down their relevant units like this and to show the calculation like this. I mean like their simplification, no need to include those things. So but remember, we are finding out the heat energy. So energy is measured from joules. So after the substitution, you put the answer and remember to put the joule sign, joules. Okay, right then. Let's head on to see the next question. Say two properties which a metal used to make the heat in coil should necessarily have. So we know that usually these heating equipments like coils are made up with materials like nichrome, right? What is the reason for this? Because, my dear children, nichrome has a very high resistance. Because of having high resistance, these nichrome substances, nichrome coils, nichrome plates, these things can be heated up to a heavy, I mean like extreme temperatures. Now, whole idea behind using a kettle, like kettle, iron, then rice cookers, those things, the whole idea behind these using these electrical equipments is to heat a certain substance, right? We are heating a certain substance or in each of those cases, right? When we are using the kettle, we are heating water. When we are ironing the clothes, we are heating the clothes. Then when we are using a geyser, right, over there also we use that thing to heat water, right? Then when you are using hot plates, we heat up certain vessels and other kinds of things, right? So in each of these instances, we heat a certain substance. In order to heat, my dear children, right? Heating means actually heat is a product created because of the resistance. If the resistance is high, then the substance is going to heat up quickly and it's going to keep on going heating, right? Heat effect is mainly given out because of the resistance. If the resistance is high, the heat effect given out is also high. So the first and important factor, right, of a heating equipment is, by using electricity, is the higher resistance. So high resistance, right? High resistance. Then the next one is, no matter they have high resistance, what will happen if they have low melting point? Then it would be terrible. Why? Because it's getting heated and it's getting heated and also getting melted, right? So it's not used. We won't be able to use that thing. Can we heat water by like if the coil is getting melted, right? Can we heat water from it? You won't be able to heat it because the whole circuit will break down. Then sometimes the electricity will also get leaked and sometimes the persons will get shocked even. So therefore, we need to use a certain material with high resistance and also it should have a high melting point too. Otherwise, what will happen? Otherwise, we won't be able to use that thing, right? So therefore, with high resistance, the other most important factor is high melting point, right? So nichrome has both of these features. High melting point. This is the next one. So high resistance and high melting point. These are the two important features. Okay. Right. Then the next question. When using this kind of a kettle, using a 3-pin plug is a must. State the reason for it. Now, it's quite important to use 3-pin plugs for these kinds of instruments, especially for heating equipments, my dear children. First and foremost thing, it draws large amount of electricity because their resistance is going to be very high. As it draws large amount of electricity, the tendency of leaking electric current into a different surface is going to be also high. In the 3-pin plug, my dear children, now usually there are 2 wires in normal domestic electric circuits, no? Live wire and the neutral wire. The third wire is the earth wire. The importance of earth wire is it helps to earth the electricity which is getting leaked from a certain surface or from a certain electric equipment. Because of that, it will trigger out the trip switch and automatically the trip switch will turn down to save the person who is going to use it. Okay. So my dear children, the whole idea of using this 3-pin plug is in order to successfully earth the electric current which is getting leaked, right, from a certain electrical equipment. Okay. So in that process, during the earthing process of the electric current which is getting leaked from a certain instrument, during that process, the trip switch is getting turned down quickly and automatically, right? So that's how it is getting important, right? Which one? Usage of these 3-pin plugs in a high electricity consuming devices. Okay, so we can write down the answer. When electricity is leaked, it helps to carry these charges to the ground. That means earth, right? So when electricity is leaked, it helps to carry these charges to the ground or else to the earth. So therefore, right, so when electricity is leaked, it helps to carry these charges to the ground or else to the earth. Therefore, trip switch will operate quickly, right? Trip switch is getting operated quickly because of that process, my dear children. So it's quite important to use a 3-pin plug over there, right? Okay, so these are the answers for the question number 7, my dear children. Now let's write down the marks relevant for each and every question for the correct responses. So I'll be there with you with the marking scheme then. Right, my dear children. So I have the marking scheme with me right now. So let's mark out the correct things for these answers then. So first of all, for drawing down this structure, right, for drawing down the ray diagram, you will be getting 2 marks, right? For marking in the 2 light rays, you'll be getting 1 mark, and for drawing out the image correctly, you'll be getting 1 mark. So altogether 2 marks for the question, for the ray diagram. Then for writing down or for stating 2 different features or the characteristics of the image created over here, you'll be getting 2 marks for any 2, right? For any 2 marks, okay? 2 marks. Then the next one. So in the next one, my dear children, for drawing the structure, for drawing the ray diagram, you are given with 1 mark, okay? So the you are given with 2 marks. 1 mark for marking this particular line or this particular light ray which is passing through the principal axis. For marking this thing, they have specifically given 1 mark. Then with the arrowheads, for marking these 2, they have given 1 mark. So altogether 2 marks for the 2 marks in total for the ray diagram. Then next one, part B, for writing down any of these 2 features, you have given with 2 marks, right? Any 2. For any 2 responses, 2 marks, right? Okay, then the next one. Then for this figure or to this figure, whatever, right, is correct, you'll be receiving 1 mark for the correct diagram. Then next one, my dear children, for the connection type, for writing down the series connection, again 1 mark. Then for calculating the equivalent resistance, my dear children, again you are given with 1 mark. Just this answer is correct. This answer is this answer is enough, my dear children. They have mentioned that thing, right? Just for the answer they have given 1 mark, right? No need to show that calculation even. Next one, for part D, you have given with 2 marks, my dear children. Okay, so the 2 marks are coming for the application of V equal IR and the substitution part, 1 mark. Then for the answer, 1 mark. It's so for the unit they have given specifically marks, so remember to put units, okay? Next one. So for the convection thing, right, for the convection, this correct answer, they have given 1 mark. Then for the application, right, for the application of the formula, for this part, they have given 1 mark. Then for the correct answer, 105,000 joules or else 105 kilojoules, both the things are correct. They have given 1 mark. So altogether 2 marks for the question, right? 2 marks for the question, 2 marks. Then my dear children, for writing down 2 important features of heating equipments or heating coils, they have given 2 marks, 1 each. 1 each, okay? 2 marks. Then my dear children, finally, for explaining the use of 3-pin plug in a instrument like this, they have given finally again 2 marks, right? Okay, for the explanation they have given 2 marks like this. So this is the question number 7 then. So my dear children, we have answered 3 questions, so 2 more questions to go. So we'll be finishing those 2 questions in our next chapter then. So I hope to meet you with our next chapter to discuss the final 2 questions in our 2022 O-level paper.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.